For this class, we will introduce the OSPF LSAs and the special areas. And for the LSA tabs, actually, we will introduce tab 1, tab 2, tab 3, tab 4, tab 5, and tab 7. Okay, so this is LSA tabs. And then, after we introduce the LSA tabs, and we will introduce the special areas. It includes the step area, totally step area, an SSA area, and totally an SSA area. So now, the first is the OSPF transmits the LSAs between routers. Okay, actually, before in OSPF basic principle, actually we have introduced the tutors how to build the neighbor relationship and how to transmit the LSA information and how to build the three tables, right? So actually for the tutors which belongs to the OSPF, first they have to build the neighbor relationship. Okay, after the neighbor relationship, we have to send the link state advertisements, right? And then the router will add the LSA information into the LSDB. So for the LSDB, we will use the OSPF algorithm to calculate the route information, and then we will add the route information into the routing table. So we have three tables, and of course, during this process, we have to use the SPF algorithm, and we have to transmit the LSA information. Okay, so next is the OSPF spatial area. For the spatial area, right now we have set the spatial area has the step area, totally step area, the NSSA area, the totally NSSA area. And for this four tabs spatial area, actually the function of the spatial area is can help the device which is low performance or which is locating at the edge physically to reduce the number of LSAs. So if we set the area to become the spatial area and the devices belongs to the spatial area, don't need to collect all the LSA information into the LSDB. So first can reduce the number of the LSA and don't need to occupy much memory resources of our device. And the second benefit is the device don't need to calculate every LSA information and then to become the routing information, right? So after this, for the router flapping, actually, we also can mirror the impact of the routing flapping for the edge device or the low performance device. And we can help this device work better in OSPF principles. So first, we will introduce the LSA tabs. So what is LSA? So LSA advances the router information and topology information to ensure LSDB consistency. So we know actually in OSPF basic pro simple part, we have introduced the LSA information actually included in LSU packets, right? And then for the LSA, we'll build the LSDB. And for the LSA actually is the route information and topology information. Okay, so next, the types of LSAs transmits in different OSPF areas are different, but the transmission modes are different. So actually in different area like the backbone area and non-backbone area and the different special area, we will transmit different types LSA information. Of course, for the LSA information now, we will see the encapsulation in our packet. So here we can see the OSPF packet and the IP packet header. So for the IP packet header, actually we capture the packet and then see the network layer, and we can see the protocol number parameter in network layer. The value is 89. Okay, and then for the OSPF packets, actually we can see the OSPF packet has two parts. First is the OSPF packet header, and the second part is OSPF packet data. So actually, the OSPF packet header we have introduced, right? It includes like the version, like the packet tab, and the menu has 1, 2, 3, 4, 5. Okay, and then has the area ID, route ID information, checksum, and so on, right? And then we can see for the OSPF packet data here, for the OSPF packet data, it includes the OSPF specific tab data and the RSA 1, 2, 3. So we can see actually in the OSPF packet here, if you want to see the detailed RS information, the packet has been the RSU. So the parameter in the OSPF packet data, the tab is 4, right? Tab is 4, it means the RSU information. And then in OSPF packet data, we can see the OSPF specific tab data, and it will follow many RSA information in this encapsulation. So this is the OSPF packet data, and with one of the RSA information will include the router information and topology information. Okay, and we will add it into the RSDB. So for the RSA information, we'll include two parts. One is RSA header, and second is RSA data. So here is the encapsulation for the RSA. Okay, and for this page, we'll introduce OSPF area division and the RSA tabs. And here we can see this topology here. And for the topology, we enable 3 areas, right? And the first is area 0, is backbone area. And second is area 1, so it's non-backbone area. And third is area 2, is also non-backbone area. So actually, first, in every area, like the area 1, okay, we can see the R1, R2, R3, R4, and another have the P2P device connect with the ABR device. And we can see for this area, every router will generate the RSA information for RSA 1, tab 1, RSA tab 2. For this 2 tab RSA information, actually, every area will generate the RS1, A1, and the RSA2. Okay, so every area will have RSA1 and RSA2. And then for the RSA1 and the RSA2 information, want to transmit to other area. So now we can see here we have 2 ABR device, right? 2 ABR device. Actually, the ABR device is connected with 2 area. So for this device, it's connected with area 0 and area 1. So for the RSA information belongs to the area 1. If we want to transmit this RSA information to another area, such as area 0, so now we will transmit the RSA 3. Okay, we will transmit the RSA 3. So it's tab 3 RSA information to other or to different area. And then the RSA 3 information transmitted to area 0, and the area 0 can help the area 1 to transmit this information to non-backbone area. It's transmitted to area 2. So all of the area belongs to this OSPF process can learn the RSA information between different areas. So this is the first situation. Okay, and the second, also we can see here for the OSPF. Actually, here is the ASBR device, right? It means except the OSPF process, such as process 1. Okay, we also have another AS. So this is the AS1 and maybe this is the AS2. So for two different AS. And here we can see the devices belongs to the AS2. Maybe we enable other protocols. Maybe also we can enable the OSPF process 2 or 3 or 4, right? So it means for two different AS, the device want to communicate with each other. So here we have to do the redistribution between two AS devices. So here we can see for the device which is to do the redistribution, and it means this device is ASBR device. So here we can see here the device is ASBR device. And for the ASBR device, actually the information want to transmit into the OSPF process 1, and we will transmit the LSA 5 information. Okay, and then for the LSA 5 information from the non-backbone area, and then the LSA information will transmit to the backbone area, to area 0. But now we will add the LSA 4, type 4 information. Actually, the LSA 5 is to describe the external area. Okay, but actually, when the non-backbone area transmits the LSA 5 information to backbone area, here we can see for the device, actually for ABR device, he will know the ASBR device, right? Because the ASBR device and the ABR device belongs to one area, it's area 2. But for this device, it belongs to the area 0. And the ASBR device belongs to the area 2. Okay, so actually the two devices don't know the location with each other. Just the ABR knows the device in area 0, and also know the device belongs to the area 2. So if we want to tell this device the location about our ASBR, so we have add the LSA 4, this type information. Okay, so for the ABR device transmits the LSA 5, and then we'll add the LSA 4 information to tell the location about our ASBR device. And then the device will transmit the LSA 5 and the LSA 4 information during this area. And then for the backbone area also have to transmit the LSA 4 and the LSA 5 information to another long backbone area, so that every router belongs to the different area can know the external network and can access to the network. So actually the LSA 1 and the LSA 2 belong to one area, and the LSA 3 is between different area. And for the LSA 4 and the LSA 5, actually it's about the external network information. Okay, so this is the OSPF area division and LSA tabs. Okay, here we can see the common LSA tabs. Here we can see the 1, 2, 3, 4, 5, 7, and right now we have introduced the type 1, 2, 3, 4, 5. Okay, so now we will learn more details about different types of our LSA. For the first tab of LSA, and we can see we also can call the type 1 LSA to router LSA. Okay, router LSA. And for the router LSA, actually, the generating router is IR device. So what is IR device? It means every device, if you enable the OSPF process, so we can call this device as IR device. So it means every area, such as area 0, area 1, area 2, or the special area, okay, and you enable the OSPF process on the device, and then the device will generate the LSA type 1, okay. So for the LSA type 1, it describes the information of links directly connected to routers. So we just can transmit this kind of LSA information inside the area. It means just can transmit the area 1 with the type 1 LSA information, okay, inside the area 1. So if you want to transmit the area 0 about the LSA type 1, and you just can transmit the type 1 LSA information within the one area. You can't transmit the LSA information to another area, okay. And so if we see this LSA information, also we can use the Show IP OSPF database, right? And for the LSA information, we also can see the routing table. So if we show IP route, we can see the O mark in our routing tables. It means it's type 1 LSA, okay. And the second is type 2 LSA information. And for the type 2 LSA, we also call the network LSA. So for the network LSA, it's generated by the DR and BDR. So also for the DR device and BDR device belongs with one area, can generate the network LSA information. So the network LSA actually can describe the broadcast network information with one area. So also we can't transfer the network LSA information to other area. We just can transmit this kind of LSA information within one area. So also the mark with the routing table is O. And then the type 3, actually we can call it summary LSA information. And for the summary LSA information, the generating router is API device, okay? So actually for the API device, it's connected with two area, maybe the area 0 and then other area is area 1, okay? And for the different area, if we want to transmit the LSA information, we use type 3. So the type 3 actually describes the inter-area information. Okay, so for the area 1, want to transmit the LSA information to area 0, we use type 3. And the area 0 want to transmit to area 2, we also use type 3 LSA information. Okay, so for the type 3, actually we can transmit in other or in different areas, okay, except the originating area. Okay, it means if the LSA information originates by area 2, so we can't transmit the LSA type 3 in area 2. Okay, so if we want to see the routing information in our routing table, we can see the OIA, and we use the show IP route. We can see the mark with the OIA, and this means this routing entry is generated by the type 3 LSA information. Okay, the next is type 4 LSA information, and we can see for the type 4 and type 5 actually is also about the external AS information. And for the type 4 and the type 4 LSA information is generated by the API device. So if we want to transmit the LSA 4 information, actually we can transmit to a different area. And then for the type 4 LSA information, it describes the ASBR location. Okay, so it describes the ASBR reachability information, and then transmit in other area except the one where the ASBR. So it means if this information is generated by the ABR device, right? And the ABR device is belongs with area 0 and area 1. And for the area 1, actually, we do the redistribution on area 1, and then the area 1 will transmit this information to area 0, and ABR will generate the type 4 LSA information, right? And for this type 4 LSA information, we won't transfer to area 1. We just transfer to area 0, and then the area 0 will transmit to other non-backbone area. Okay. So next is type 5. The type 5 actually is AS, external LSA information. And for the type 5, LSA information is generated by the ASBR device. So the ASBR device actually we do the redistribution on ASBR device. So the ASBR device can generate the external routing information, and then we will add this external routing information to become the type 5 LSA information, and then transmit to other area, maybe from the non-backbone area to the backbone area, and then the backbone area transmit to another non-backbone area. So we can transmit the type 5 LSA information in whole AS. Okay. So in the routing tables, we can see the OE1 or OE2. These two tabs, maybe the type 1, maybe the type 2 external routing information in our routing tables. Okay, and the last is the type 7. Actually, the type 7 is for the spatial area, and the spatial area, we call it an SSA area. If we enable the SSA area, okay, we will generate the type 7 SSA external information. And for the type 7, LSA information is generated by the ASBR device. But for the ASBR device, actually, it can transmit in the SSA area. So for the type 7 LSA information, if we want to transmit to other area, how to do? So now we will transmit the type 7 LSA information to become the type 5 LSA information. Okay, so for the type 7 LSA information, actually, we just can transmit the type 7 LSA information in an SSA area. Okay, so we have to remember this. And then we can see the routing entries. If we use the shoe IP router, we can see the ON1 or ON2, this two mark in our routing tables. So this is the LSA tabs introduction. Okay, next. And for this page, introduce the LSA packet header format. And for the first is the LSA tab, right? And we know the LSA tab includes the type 1, type 2, type 3, type 4, type 5, and type 7. Okay, and for every tab, we also can call the router LSA, network LSA, summary LSA, or external LSA information. Okay, so this is the LSA tab. And next is the link state ID. It's a LSA name, so we can say for the same tab, two type 1 LSA information. So the link state ID is different. It means the content is different. Okay, and the third is advertising router, and we can simplify it as ADV router. For the ADV router, actually, it means the LSA information is generated by which router. Okay, we use this parameter to identify it. And then as link date. For the link date, it's used to present the content of the LSA information. So for the different tab and the content with the link date is different. And then the option. So if you want to add some other content, you can use the special option of LSA information. Okay, and then the net mask. And next is a tanged router. It means the neighbor router. And the floating scope. The floating scope is means the LSA information can be transmitted in which area. So such as LSA 1, LSA 2 can transmit within one area, right? And for the LSA 3 can transmit between two area or different area, okay, except the own area. And for the LSA 4, actually we can transmit to another area, but except the LSA4 information generates by which area, right? And then the LSA5, right? And for the LSA5, we can transmit in whole OSPF process. So this means the floating scope. So different LSA tab has a different floating scope. This is the LSA packet header format. And except the LSA packet header, we also have the LSA date. Okay, so this is the first part about the LSA information. And next part we will learn more details about every tab LSA information.